And we're back. So I take my explosion 1 scene and I want to remove many objects here. You can see I name it 0 render version 1. So as I said, I want to create the separate file for render. And I want to leave here just the cache. So I'm going to leave the ocean because I will render the thing out. I'm going to keep, I don't need the ship Vdb we create. I think we need just a ship render. So we can remove all the thing here, and I can even remove from the group. So the ship animation is our animation. We don't need it also. Well, we can leave it by the moment, but I will remove it later. So let's remove this. I can keep ocean because I will render the thing. I can remove the explosion. Yeah, I can definitely remove ship element. If I want to, we can easily copy the whole, part of the scene from any project, because we can simply copy it with Ctrl+C, Ctrl+V. With the ship import, we don't need the explosion animation. We already have the render ship. That means that we will render our elements. But we begin rendering with not with the geometry, but with an explosion. And the reason for this, because I want to create the volume light which will have an influence on our geometry. That's why I want to work with geometry in the first, and then I will use the rendering of all other geometries, debris, additional element, and all other things. So let's make the thing a little bit bigger, and then put this ship Vdb over here, and let's rename it. It's going to be my RBD cache. Oops. RBD cache. So all what I have here is just my ship render, which is cached file with our fragments. I'm in manual mode for now because I don't want to update this thing each time when I want to change something. And the thing I want to do here is basically create two null objects. So the first null object will be as a null with render. So let's name it render and connect it here, or actually connect it here, right, and set the empty null object with a display flag. So I set display flag over here and set the render flag on this node. As an always, even if we go inside of each node, I don't want to have an updating. So if I want to look at this geometry in the viewport, I can simply check the ship render button and enable display here if I want to look at that. In all other things, I don't want to look at this. And the reason, because we are going to have a lot of different caches here, and sometimes if in each node we're going to load all information from our cache, it can be very heavy for our project. So that's why I keep my null object empty here, and I won't display nothing inside of this node. And even if I enable my RBD cache display option, even if I go to auto update mode, you can see that there's no changing. There's no any object on this frame. All right. So why I keep my ship import? I keep this geometry because till frame 25 I will render my original geometry, and then on frame 25 when our elements begin to fly, when I create fragmentation, I will use my RBD cache. So we can do this manually. We can make a switch node for rendering. Anyway, we can do this because till frame 25 there is nothing happen. Just the water simulation and the ship, so we can use the R-ship render till frame 25. And after frame 25, we're going to render out all elements separately. So now let's talk a little bit about rendering, how we can do this, and what the main methods we can use for render out our results. In our training, we're going to use the mantra. For all of you who want to use the Arnold or maybe Redshift, I'm not using those render. I use the Arnold sometimes. Sometimes I visualize my explosions in 3ds Max using V-Ray, but maybe you know that V-Ray is also can be applied for Houdini, but I'm not there is no V-Ray for Houdini here in my computer, so maybe later I will test this and maybe I will use a V-Ray for Houdini, I don't know. But I like the Mantra, render, but the main problem, or like main huge minus of this Mantra, is that it's pretty slow. So if you compare like Arnold or Redshift, which can use the GPUs, not CPU, GPU, can be a little bit faster. But I work with Mantra many years, and what is the most big plus for Mantra is a huge flexibility, because it's like a native render for Houdini, and there is many different things we can set up in Mantra, and it's very it's very flexible. So we can tweak anything inside of Mantra, any stuff, beginning with the sampling, working with the blur and other things. So we can optimize our render if we want to, and make our render time a little bit smaller. But again, Redshift, especially if you work with volumetrics, sometimes can be a little bit faster. I'm not working with the Redshift, the main reason because I don't have powerful GPUs. I work with simulation in different softwares, and those simulation use the CPU. So to have a powerful workstation which have a very powerful CPU and GPU is a little bit expensive for me. So I use the CPU mainly. All right, so what we have and how we can apply our render settings. Well, the main thing is we can go into a few different ways with rendering. The most maybe simpler way is we can take all our elements into one render. We can separate them using the using the mattes, using the masks, the cryptomat, and all other things to separate them in compositing, to make some compositing stuff like color correction or something like that. But the main thing, if we use all objects in one frame, there is a few negative things we will do. And the first negative thing is that we can't adjust or set up our rendering just for all our elements, because we can separate our elements into two different groups, is geometry and volumetrics. For those groups, we need to set up the different rendering settings, because for volumetrics we need to give more sampling into volume. We need to work with the lights, like standard lights and volume lights. For the geometry, we can apply the environment light, because we need to have reflections, and we need to take care about all those things with geometry, which is reflection, refraction, the nice sampling with geometry, bouncing options, and all this stuff, which we don't need to use with volumetrics. Okay, so that's why we have a different settings for volumes and for geometry. That's another reason why we need to render them separately. But the main reason why we need to do this separately is because it's very important for compositing. If we the more elements or the more ways for compositing we're going to have, the better. Because if we render out each element like a geometry with many different AOVs, with many different layers we can use on compositing, the better compositing will be. So we can change a lot of stuff. I use a Nuke to work with CG scenes, so there is a lot of possibilities to change and optimize the scene to make it much better. And that's why we will render each element separately. So we can divide our render into such an elements like ship. So the main geometry for our ship, including debris, because debris is the same geometry, and I will render out the both element and ship and debris at once. You can separate them also. The another element will be the explosion. So explosion. Then we'll render out each secondary element separately also. It will be our fire trails, it will be our sparks and trails also, and the liquid. The water surface and the flip simulation with the white water will render out also separately, and then we're going to combine those elements in Nuke to have a complex scene. For all of those elements, we're going to have a different settings in Mantra, and we will render them using the made objects. So that we need to understand that all those objects, they depend with other ones. It means that if we have a distraction with the geometry, we need to have the light influence from the explosion. So we need to create a volume light from the fire, and this light should light up our geometry, our ship. Also, we need to understand which part of the ship we will cover with explosion, what we can see, what we can't see. So we're going to use a lot of different matte elements, and we need to understand the main principles, which element we want to add as a matte element, or which element we can go and add to these phantom objects so they can apply just the shadows or reflections, but they won't be cut from the scene. So let's go ahead. I'm gonna leave this RBD cache by the moment because we're gonna back this in the next lesson when we will render the geometry elements. And ocean also, we're gonna apply this rendering when we create the flip simulation, so we can apply an ocean and the flip simulation at once. So the next thing is an explosion. So I select the simple, I add a simple geometry node, and let's call this explosion. Explosion. All right, we can uncheck this guy. Let's dive inside. I want to copy my file from the last come on, what's happened here? Something wrong with the list license. Okay, don't need to do this. Alright, maybe I will resave this file to make sure that all's fine. I don't know why, because I have non-commercial license here also on the next window. Okay, I resave this file again because I don't have an errors on my project. You know, it can work fine, but at some level it can create something bad. And we're back, so I make the same project again and save it as 0 window. And go dive into explosions. So what we can do, as you can see, this is our cache from my second version of the fast explosion. So what we can do here, in this moment I even don't need to look at the explosion. When we want to work with shading, we're gonna see this. Before we go into the shading, I want to work with the fields. If you go to explosion, let's update it somewhere in frame 20 or 36, let's say. And let's update because I want to look at my fields I have from the cache file. I pop it 1b2 and animate cam. Hey, there's something wrong with my camera. Let's change the animation frame. Come on. That's interesting why it's looking from the another angle. Let me enable the ship import just to make sure that all's fine. Where is my main elements here? So our geo I can update. It takes some time for updating geometry. I just want to make sure that this explosion in my ship and not somewhere on the side of the ship. Sometimes it can be when we loading the cache wrong, or the wrong cache, it can be in different places. So where is my this is my ship, and I want to look at my explosion. Let's go to auto update mode. I just want to make sure that my camera is correct and explosion in the right position. Yeah, explosion is in the right position, and let's look at the camera now. Now it's all fine. So sometimes it's happened that the camera can't understand where it is, or where is explosion in this case. So we have an explosion, and if you look here, we can see the different fields inside. So we already know that we have the density field, which is smoke. We have a velocity field, which I definitely, oh, I don't know why velocity field is not down sample. That's my mistake. I need to get back to my caching, I remember that I changed the settings for velocity, so it should be much smaller. Anyway, if it is, we're gonna work with that. Now we have a temperature and we have the flame. So which field we need for visualization? As you may know that the density field use it for creating the smoke. So we can apply a different density, we can apply the different color for the smoke, and that's how we can correct the visualization of the smoke. The temperature and the flame work with the fire, because the temperature can create the color depending on the temperature. As you know, the lower temperature create more like red color, and the higher temperature create very bright, closer to like, you know, the bluish tint color. So it creates the colorization, and flame can create the intensity for us, because the flame as the temperature is the float value, and it can say us where our fire can be more intense or less intense. All right, so we can play with intensity and we can play with the color. The velocity can use for the motion blur. Sometimes we can use it for the time remapping, especially with explosion. Sometimes we can, you know, dry our cache simulation if we don't want to recalculate our simulation. Let's say our explosion is rising up very fast, we want to slow this down. We can simply go to the time blend node and using the interpolation method, using the velocity, we can slow the simulation down. All right, so but before we go into the shader, I want to apply a very interesting method which I saw in this month in one of the webinars with Houdini. They call this method creating the scatter field. I call this method as the diffuse field, because in many in mathematics way is we create a diffusion, we blur our field. So to create a more interesting like a picture of the flame, we can play with the temperature. As I said, temperature field used as the field for the color. And in many cases, when you create explosion, our fire is very flat. So we have some gradient from the red to the bright areas, but this gradient is very flat. Even if we create a different disturbance and the different turbulence field, sometimes it won't create a proper result, especially in the beginning when we have a big mushrooms because of the big velocity and expansion. So we break in the shape, and mainly the shape is nice for the density, but not such good for temperature. So how we can break mesh, not mesh, I think that this can break color for our temperature. Let me show you one simple example. We can take our explosion and we can apply the blur field. We can apply the Vdb smooth, so it's actually applying like some kind of a blur filter, and we can deploy different radius, blur radius, and that's how we can create a nice field which we can use for visualization. So how we can do this? We have an explosion and we can take the temperature from this explosion. So let's apply the null object, and that's gonna be our explo out, or explo in, I guess. And let's correct something. With the blast node, I can keep just the temperature. So let's now in here. I think that I can, open this in all window, because visually we won't see nothing here. So all we can do is analyze the fields. So in this case, what I want to do, I can say that if your name is temperature, and in primitives, let's delete non-selected. So in this case, after the blast node, I guess I need to keep my picture on, because all my calculation works just if we have some image here. If you go to information, now you can see that we have just a temperature field. We remove all other fields from this. All right, so now let's play with this density. Let's can call this keep density. Keep pump density? No, just keep density. Okay. All right. So and the main tool which can apply the smoothing or the blur option or diffuse inside our field is node called Vdb Smooth. So the Vdb Smooth is a very interesting option. It allows us to apply the smoothing to our fields depending on the voxel radius and iterations. But before we do this, we definitely need to convert this into the Vdb volume. So using the convert Vdb, we take our volume and convert it into the VDBs. So nothing more here, just simply Vdb field. Now you can see that we have this temperature field over here. So if you look at that, you can see it's like a green color, and after we convert it into the Vdb, it became like a blue here. Also, we have the less voxels here, and the reason why we have less voxels with the same voxel size, as you can see, 0.075, is because the Vdb creates just voxels where we have some information. So if we don't have a temperature around all this bounding box, if we select and deflate by shading, I don't know why we can't see it because I need to update it again. I hope we should see the I don't have temperature visualization. So if you go to explain, we can see the bounding box, and you can see that this box, mainly many voxels inside of this box, they doesn't have any information, or this information will be equal to 0 because there is nothing. There is no temperature, or this temperature equal to 0. There is no density, heat, or something, in our case flame, or something else. So there's a lot of empty space, and in the standard Houdini volume, it will calculate this empty space also. So that's why we have like 40 million voxels, because it's simply, we can multiply this by this by this, and we now have 39 million voxels because we have a dimension of this bounding box. But when we create the Vdb, we're going to convert this thing, and you can see that this box is much smaller because we avoid the empty space, and the amount of voxels is much smaller. I really don't know why it doesn't convert to Vdb after my explosion simulation. I need to back to my explosion scene and look at that, because as I remember, I converted. Anyway, now we have the Vdb temperature. So what I want to do, I want to keep my temperature, but I want to take my temperature and send it to the another field. So we create some kind of temporary volume field, and I call this field the diffuse field. So we can use the name node, and we can apply it to convert Vdb. And what we can do in this name node, that I select my temperature, and I want to add another name called diffuse. Oh, come on. And this field called diffuse. And then I want to merge them, and with the reactivate Vdb, reactivate, Vdb activate, Vdb activate. So take this field and this. So now I can combine those elements. So you can see that now we have just a diffused field. If I want to use my field here, so we can select my diffuse, and as a reference, the bounding group, I use the temperature. All right, and activate using VDBs. So now we have the diffused field, and you can see that we have the same options, the same settings as the temperature field, because we use a reference. All right, so now let's just not, I want to copy the copy operation. Let's disable value. So now I'm gonna play with this diffuse field, and what I want to do, I want to apply the Vdb smooth. If I select this guy, and I want to apply a different filters, different filter values for the same field, scatter, and then merge them together. So if we want to visualize this field, we can simply use the volume visualization node. because, well, it's not very good when I explain something, but we can't see nothing in the viewer, and we can't understand what happened, why we do this operation. So volume visualization, we can apply it here and connect it to the Vdb Smooth. So we can also merge those elements. We can merge them, so we can take our elements from the explosion and add our diffuse field over here, and then apply the volume visualization node for those. But inside of the volume visualization, when we look at the settings here, as a smoke, I'm going to use the density here and here, but with an emission, I can use the smoke, and let's make it more darker, because I don't want to have a white smoke. And now we can see it's pretty good, it's working. And if I go to emission, I'm gonna use, as I said, we can use two different fields. One for emission is like intensity, and another one for the color. So mainly we use flame as an emission and temperature as a color field. But in this case, let's increase the emission scale to 1. I can set the temperature as an emission field. So the bigger temperature value, the bigger you can see the brightness. All right, the bigger emission. And no need to use a ramp. And as a diffuse field, I'm going to use my as a color field, I'm going to use my diffuse field here. All right, so what I can do now, so you can see here we have a very bright areas, because with an emission color ramp by default we have this white color. I don't need to have it. So let's add more like an orange, okay, more red color. So now you can see a nice yellow to orange transition. You can keep it maybe not such saturated, maybe like here can be good. All right, so there's something happened here. So we have a lot of intensity here. So we can definitely use the color range. So using the color range, we can set what color I want to apply to the values here. So we can set the maximum range, let's say 3. So the orange color will be, it's not orange, like more pink. Red color will be applied to values bigger than 3. And we can set like a lower range, like 0.2, and it will apply our black color to, let's say, like 2 here. I just want to look at the range, like 5. So you can see there is a lot of very bright areas. 5, let's get 3. So all elements, actually all voxels, which will have the settings lower or value diffuse lower than 3, will be dark. So let's what we can do here is we can play with the color range, not just for our visualization. We can play even here in our setup for our VDBs. So what we can do, we can use the volume wrangler, and that I can change my range for temperature or for diffuse field, it doesn't matter. We can change the range for those. So if we take our temperature, and we can say that let's fit our temperature field. So let's set the channel, the min temp, come on, be good. So the another input gonna be the maximum temperature. Okay, and we add 0 to 1. So it means that now if we apply those controls for the volume wrangle, Hey, where you are? Here we go. So we have an ability to set the minimum and the maximum temperature range and normalize it to the range from 0 to 1. And the reason why it's good, because if we apply this, it's can help us to work with shader when we have the normalized temperature. So let's set those values to, like, I don't know, 0.3 and 3. So the minimum temperature is going to be 0.3 and the maximum temperature will be 3. And now you can see a difference. Well, if we have 1, so you can see for a moment that we have the gradient. That's interesting why we have sometimes it creates an instant result for us. Anyway, let's set it to 3. And now what we can do is the set, depending of your the temperature values, you can set your maximum and minimum ranges as you want. All right, so let's look at the difference with the Vdb smooth and without it. And mainly if you apply the Vdb smooth, you can see a slightly changing here. So because by default we have a values here 1 and 4, so I don't need to have many interactions, so I set it to 1. And the filter radius, I will apply a few different filters. So basically I want to apply a different diffuse level. So diffuse level 1, we're gonna set like the voxel radius of 2. Also, we're gonna copy this diffuse and paste it. Oh, come on. Anyway, it should work, but I'm gonna save it as a version 2 because I really don't want to have bad projects. So run version 2. Now I'm gonna use the same diffuse but with level 2, and with the next Vdb smooth I will increase the voxel radius to like 3. So now I have 2 different Vdb smooths with the radius of 2 and the radius of 3. Now we need to combine them. And as you remember, we can't just merge them here because I don't want to create 2 the same fields. I want to combine those fields. So I need to merge them inside of one field. So what we can do is we can use a Vdb Combined Node. So it's very simple node. In fact, we can take one field, another one, and we can select the operation I want to use. I don't want to use the copy, I want to add. So we take the both information from one and another field and add this field here. All right. So, but from the second input, I want to multiplier use a little bit smaller. So let's say 0.75. So 25% smaller, and let's connect it to this Vdb Combine. Go to volume visualization and let's look at the difference. Again, maybe it's not very visually good here in the diffuse. Maybe let's play with the density scale a little bit more. Okay, yes, density. The thing is, we should play with the density and the temperature because we, should see a nice gradient transition between those elements. So let's switch to diffuse level 1, diffuse level 2, not too much for now. So let's increase the amount of levels and we go to level 3. I don't know why it's happened, why it's showing me the error at this stage, but now let's increase the filter voxel radius to like 4. Or let's say it's 6. I'm gonna keep the amount of iterations. So the Vdb Combine again, let's apply it. And now I'm gonna apply for input A, we're gonna use the first Vdb Combine to merge those elements with our diffuse level 0.3. So in this case, we can use the same add option or add operation. And let's change the multiplier to like 0.7 maybe. So it was 0.75 and here let's say 0.7. And yeah, another thing I want to do here is I don't want to use a resample. So let's off this thing. We won't use a resampling, and off is here. And in the tolerance, so let's disable all those options we don't want to use. And let's apply another Vdb Combine. So again, we can see the slightly changing, but it's not too many we can see from the volume visualization. Even if we apply the maximum resolution or a bigger resolution, we won't see too many changes here. Let's switch it to diffuse level 1 and diffuse level 3, so we combine our elements. It became a little bit more brighter, but also what we can have with this, we also can have a nice structure we can use for visualization. Okay, so let's use this. So now we have different fields here. Now we have a density, we have velocity, temperature, and the flame, and we have a Vdb diffuse field. All right, which is much smaller. I definitely need to convert all those elements into VDBs. Okay. Now let's put those fields here to the null object. This null object as an always will be the render. Set the render flag in that. And create the empty node. So let's save the project again, and now let's talk a little bit about shading.